If you peek inside just about any toolbox, you're going to find a claw hammer. It's the classic, right? The go-to for woodworking. But sometimes sitting right next to it, you'll see its tougher, kind of mysterious cousin, a hammer that's not built for wood at all, but for metal. So on the left, there's our old friend, the claw hammer. We all know what that claw is for, yanking out nails. But then you look at the one on the right, the ball peen hammer, and you've got a puzzle right there in the name. What in the world is a peen?
All right, to really get this tool, we've got to crack the code on that one weird word, peen. Turns out it's the key to its entire reason for being.
So here it is. Simply put, the peen is the business end of the hammer when you're working with metal. See, one side has a normal flat face for striking, but the peen, that's the specially shaped part, designed specifically for forming and moving metal around. And what's really cool is the history of the word itself. Peen probably comes from an old Scandinavian word that literally meant to beat thin with a hammer. So right from the get-go, the tool's name was its job description. How cool is that? Okay, now that we've solved the mystery of the name, let's put these two hammers side by side. This is a fantastic example of that old design principle, form follows function. Each one of these is purpose-built for a totally different job. Let's break it down. First, the head structure. The claw hammer has that V-notch claw, perfect for grabbing nails out of wood. The ball peen? It's got that smooth, rounded ball for spreading and shaping metal. But check out the material difference, because this is absolutely crucial. Yeah, it really all comes down to durability. A claw hammer's head is tough, for sure, but it's not made to be smacked against other hard metal things like a chisel over and over again. The ball peen's head, on the other hand, is made from hardened and tempered steel. That means it can take that punishment all day long, without chipping, deforming, or shattering. It's built for metal-on-metal impact. So to really see what peening is all about, we've got to watch it in action. And one of the most basic, fundamental jobs for this hammer is forming a rivet. It's this ancient, super effective way to join two pieces of metal together. It's a really elegant process when you see it. You actually start with the flat base of the hammer, but you're not driving the rivet in. You're gently tapping it to spread the metal out, kind of like a mushroom cap. Then you flip the hammer over to the ball end. With a series of circular strikes, that rounded peen finishes the job, creating a perfectly smooth, strong, rounded head. This process also work hardens the metal, making that joint incredibly tough. Okay, so riveting is pretty neat, but you might be thinking, in an age of fancy CNC machines and laser welders, is a simple hand tool like this even relevant? Well, the answer is a definite yes. It matters more than ever. And this quote just hits the nail on the head, so to speak. Automated tools are incredible for speed and repetition, but they just don't have the finesse, the human touch needed for detailed, hands-on metalwork. Sometimes you just need the feel and the precise control that only a hand tool can give you. I mean, just look at how widely it's used today. We're talking about everything from an auto mechanic carefully tapping a part into place to a jeweler adding a unique texture to a piece of silver, all the way to heavy-duty work on ships and airplanes. The ball peen is a true workhorse, a testament to a simple, brilliant design. So the big takeaway here is pretty simple. Knowing your tools is key to doing good work. A claw hammer is for wood, a ball peen is for metal. And choosing the right one isn't just about making the job easier, it's about safety, precision, and ultimately, craftsmanship. And that really leaves us with a final thought to chew on. Every single tool, from the simplest screwdriver to the most complex machine, has a purpose baked right into its design. It's got a story to tell, a piece of engineering history just waiting for you to see it. So what stories are hiding in your toolbox?